absolutely want to protect if you want to have any reliable information. And on top of that, location awareness or awareness of the absence or presence of certain devices in a certain area can help you a lot. So you can leverage on location information. Equally, I didn't mention it here because there's no time. You can build much more efficient security protocols on top of secure time synchronization, for example. If you have time, you are really, really in a good starting state. All your broadcast authentication protocols, they will all benefit hugely. You usually need at least half. I mean, you need half of the messages that you would usually transmit. So you can use timestamps and so forth. And for the end, I just put some publications that relate to this talk. So on SecNav, on integrity coding, on location verification, and on device pairing protocols. We have a catchy website on securelocalization.com, which for now doesn't do much but reroute you to our web pages. But hopefully it will contain a much more detailed description of all the existing schemes, not only ours, in that field. And this is my email if you want to contact me. And I hope I think I'm pretty much on time. And if you have any questions, I'll be more than happy to answer them. So thank you.
I'm just curious that can you tell me what's the accuracy of using a signal strength to estimate the distance?
So the accuracy of using signal strength to estimate the distance is extremely low. I mean, if you use RSS-based localization or ranging, then you will hit many problems. Even depending on if your antenna is facing down or up, or if your node is so it's extremely tough. Many researchers have shown that, and I think you can use it only for some coarse-grained localization. So probably the best that you can do in those scenarios would be something like beacon-based localization, so range-free localization. You can obviously benefit if you use some RSS-based space fingerprinting, so you can fingerprint spaces, but that's not something that we looked at here. Related to SecNav, for example, for us, this beacon-based or range-free was only one example of how we can simply implement it. Those schemes are very appealing because they are simple to use, but they are not very good. Yeah?
A couple of comments. Your talk was excellent. Really understood.
Thank you.
We tried to do some work in providing privacy, which means we don't want people to know exactly where we are, when did we send the signal, and all those things. And we use the geometry. There's a paper in Transactional Mobile Computing. I was just wondering, is there any way we can provide somebody who doesn't want to tell anything, but want to participate, doesn't want to tell about the location? Is there any way you could protect his privacy?
Okay, so first of all, we are working on it. We have two projects that are kind of competing, and that's a funny story. We have a project also on device identification, trying to invade privacy, and then we have a project within this project on secure localization. We have efforts to provide location privacy. Is there a way? Well, if your system is based on location, on awareness of location or proving certain location, then it's extremely hard. Equally, from my past experiences with devices which you can, I think we discussed it already, so which you can fingerprint, so you can actually extract a fingerprint of a sensor, of a node, of a radio. So each radio is kind of unique, so when it transmits, it gives you a unique fingerprint. So you can even do that, right? You can set up an infrastructure that for any message that you send will do time difference of arrival or RSSI-based measurements and will try to infer where you are. Now, trying to hide location information, it's a very, very hard problem. I don't have a solution for it, and I would love to hear someone who has, but I don't think it will come that soon. I think it's a very, very difficult problem. Maybe in a multi-hop scenario where you can leverage on some information hiding, some mixing that can work partially within a given locality, but it's a very tough problem. If the attacker is assumed to be omnipresent, it's a very tough problem.
But what I'm realizing is that you're making it very difficult.
Among other things, yes. Yes?
I have a couple of questions. If you assume that there's time synchronization, let's say between satellite and the GPS receivers somehow, then a simple solution where like the satellite signs everything would be enough?
Okay, so if you assume that there is time synchronization between a satellite and the devices, then you are then you are in a slightly better position, okay, because you are still measuring time. Okay, so you are still measuring time of flight, which can be delayed by the attackers, right? So you are still going back. So there, the solution of using verifiable multilateration still applies. So you still need something like this, right? If you have an external.
I was actually referring to the secure navigation, to the first problem.
Okay. Yeah, yeah. So if you have a secure time synchronization there. So what you are saying is that you would send signed messages that could be overshadowed by the attacker. Very simple, right?
Okay, but I guess in this system you also assume that the attacker cannot jam those beacons.
No, he can jam, but it's just that then a whole bunch of ones will appear on your device, and you will know that the messages
he
are.
Jam and just broadcast his own beacon, for example?
No, because your beacons are constantly being the legitimate beacons are constantly being sent, right? So at your receiver you will receive both the legitimate beacons and the attacker's beacons, and the only thing that the attacker can do is either amplify your ones or turn zeros into ones. So he cannot do much. I mean, because jamming doesn't happen at the sender, it happens at the receiver, right? So unless he wraps a foil around the receiver, I think you are perfectly fine. Yeah.
I think you also made future security issues much easier by getting control of this problem.
That's what we are kind of hoping to achieve, to provide basic primitives for future networking functions. For example, if you want to do secure routing, then knowing location securely certainly helps, right? Having time synchronization will reduce your overheads. Knowing location securely will, and also verifying location securely will help you with any broadcast, with any multicast, with any aggregation, with compromise detection. I mean, provides you. So the main idea here, when I go back when we started, was, well, let's wire the wireless networks. Let's have the topology on top of the wireless networks, because what you have in the internet that's pretty much what you have, kind of, right? You have routers, you have certain hierarchy, so you kind of know where people are, where that device is. You can sort of trace it, right? It has a certain structure. Here there's no structure, so you want to ground it. You want to know where they are, and when you know where they are, it's much more easier to detect who's doing what and how to prevent it then.
So these problems are not in the internet.
Well, these problems are. Okay, so there were some works. There were some projects and papers that are trying to tackle, where a node is when you communicate online. Where is this node geographically? If there is no IP spoofing and so on, then you can pretty much